Okay, so in this lesson, we're going to be factoring. So when we're factoring, you're finding another way to write a polynomial. So we've already been discussing polynomials, the sum of monomials. You're just writing it a different way. It's going to help us once we get to solving later on. So it says the blank is the largest monomial that divides evenly into your polynomial. This is the greatest common factor. Identifying the greatest common factor, I'll just use GCF now, is your first step in factoring any polynomial expression. So you're always checking to see if they have anything in common. So the GCF of 5x to the fourth minus 15x cubed plus 20x squared would be 5x squared. So they all have a 5 in common. And then notice they all have a variable x in common, so you're always taking out the smallest one. So if they all have it in common, always pull out that smallest one. So the smallest variable would be x squared. So to determine what's left, when you take out the GCF, you're going to open parentheses and you're going to divide it and put what's left. So I'm dividing each term, so that way when I multiply the factored polynomial, it verifies its accuracy. So when I multiply it back together, it should give me back the original, the initial expression. Okay, so that's what we're going to do just on A, B, C, and D. So we're just looking for the greatest common factor, and then we'll find or move on. So it says identify the greatest common factor, and then you're going to factor it. So look at all 4 of these terms. The greatest number would be 2, but then I have to look at the variables. Notice they all have an A. The smallest A that they have in common is just a regular A. Look at the B. The first one has a B, the second one has a B, the third one does not have a B. So we cannot take out a B because they all have to have it in common. So the GCF of this would be 2A. So you always put your 2A out in front and then you open parentheses. So I'm dividing all of it by 2A. So 12AB divided by 2A would be 6B. And then 14A squared B divided by 2A would be 7AB. And then 2A squared divided by 2A would just leave you with an A. And negative 8AB squared divided by 2A would be negative 4B squared. Okay, so if you wanted to check it, what you could do is just multiply this back through. You get 12AB. You get 14A squared B. Remember, we were doing this the other day. You get 2A squared, and you get minus 8AB squared, which is exactly what we had up here at the top. Okay, so this would be my answer when I'm taking out the greatest common factor. So to check it, you're just multiplying it back through. These should be equal to each other. So factoring is just another way of writing a polynomial. It should be equal. All right, let's take a look at another one. So part B. First thing I notice is there is a negative sign on the very first one, and we always want it to be positive. So go ahead. We know we're going to take a negative out. And then the greatest number that will go into all 3 of them would be a 4. Look at your variables. We have a U on all 3 of them. And looking at the smallest, that is a U squared. So remember, if they all have the variable, you're going to take out the smallest one. So to find my answer, I'm dividing each one of them by my GCF, which is negative 4U squared. So I'm going to open parentheses. GCF always goes out in front. And then I'm going to divide it. So when I divide it, I should get 3U squared plus 7U plus, now negative 4U squared divided by negative 4U squared, you have to put a number there. So that would be a 1, any term divided by itself. Again, you can check it by multiplying this back through, and it should equal this original. So there is my answer. So this is just taking out the greatest common factor. So part C, I'm going to do the same thing. I'm going to find the greatest common factor. So 5, 9, 2, notice the only thing that would go into all three of them would be a 1. So that's really not necessary if we take a 1 out of it. It gives us the same thing. But notice they also have variables in common. So notice they all have a q. The smallest one is just a q. So actually the only GCF we have here is a q. So I'm going to write the q. And then I'm dividing each one of them by q. So that would be 5q squared plus 9q, and then minus 2. So that's all on these, we're just finding the greatest common factor. Okay, so let's look at part D. So first thing I notice is the first term's negative, so I want to take a negative out. The greatest number that will go into all three of them would be a 3. And then they all have an x. So look at the smallest one, which is an x squared. So that would be the greatest common factor of that variable. So I'm going to take out a negative 3x squared. I'm just dividing each one of them by that. So whenever I divide it, that's x squared plus 2x minus 15. So again, on those first four, we're just finding the greatest common factor, and then we'll talk about later on how we can keep going. Okay, next part. Difference of squares. So difference of squares means you're subtracting. Squares meaning perfect square numbers. So a perfect square number would be a 4, a 16, a 9, things like that. So any number multiplied by itself. So 1 times 1 is 1. 1 is a perfect square. So 2 times 2 is 4. 4 is a perfect square. 3 times 3 is 9. 9 is a perfect square. So you're going to have to be able to recognize a perfect square number. So this right here is called a difference of squares. Notice we're subtracting. Notice a squared is a perfect square because a times a is a squared, and then b squared is also a perfect square. So to factor it, basically you take the square root of both of them. So square root of a squared is a, and then take the square root of b squared, which is b, and then one's going to be a plus and one's going to be a minus. If you were to multiply them and use FOIL, it would give us back that a squared minus b squared. Okay, so we're going to factor each expression. First thing we always look for is a greatest common factor. So keep that in mind. That's your first step every time. So notice these two do have a greatest common factor. I have to do that first. So my GCF is 3. So I'm going to divide both of them by 3. That's going to leave me with 9r squared minus 1. So after I have factored out my greatest common factor, I need to look at how many terms I have. Notice I have 2 terms, so I want to check for difference of squares. We are subtracting. 9 is a perfect square, so is 1. So I'm going to bring my GCF down, and I'm going to set up 2 binomials, so 2 sets of parentheses. When I take the square root of 9r squared, that gives me a 3r. So 3r times 3r gives me 9r squared. And then the square root of 1 is 1. So I should have a plus 1 and a minus 1. So 1 times a negative 1 is a negative 1. Again, these should be equal. So if I were to check it and use FOIL, that's going to be 9r squared. That's going to be minus 3r plus 3r minus 1. Notice my middle terms cancel. This is exactly what I wanted it to equal because that was that inside piece. And then you can multiply by that GCF that we took out for it to equal 27r squared minus 3. Okay, so this is the correct answer here. Okay, so B. First thing we do is check for a greatest common factor. They do not have anything. So then notice I have 2 terms, so I want to check for a difference of squares. So I'm going to write no GCF. There's not a number that can go into both of those. Okay, so I'm going to check for difference of squares. 16 is a perfect square, and so is 81. So I'm going to set up two binomials. So I'm going to take the square root of 16m to the fourth. So that would be 4m squared and 4m squared. If I multiply those together, it should give me 16m to the fourth. Then 81, square root of 81 is 9. I should have 1 plus and 1 is minus. Okay, so after I have factored out, or after I factored my difference of squares, I need to look. Now, anytime I have a 4 here, anytime I'm taking the square root, I'm going to end up with another squared term. So it could possibly be a difference of squares again. So this, we cannot factor sum of squares, but we can factor difference of squares. So I'm rewriting 4m squared plus 9, because that's sum of squares. I cannot factor it. There's not two things that I can multiply together to give me 4m squared plus 9. But there are two things that I can do. I'm going to do a different color to factor this piece of it. If I can take the square root of 4m squared, which is 2m, square root of 9 is 3, and 1 is plus and 1 is minus. So if I were to use FOIL, I would end up with that 4m squared minus 9. Let me show you why right now this cannot be factored. So some of you might think, oh, well, why can't I do 2m plus 3 times 2m plus 3? The reason you can't factor this is because when you use FOIL, you end up getting 6m plus a 6m in the middle plus a 9. Those two middle things are not going to cancel out. So you're not going to end up with a binomial. Okay, so you cannot factor sum of squares. You can only factor difference of squares. So this is my final answer here. Okay, so let's take a look at the back. So I am factoring. So this back piece, it says quadratic form. This is a quadratic form where u is an algebraic expression commonly as x squared. So this is called a quadratic form trinomial. So it's a trinomial, there's three terms. Okay, so anytime I have a quadratic form trinomial, I want to use sum and products. S is going to be representing the sum, and then P is going to be representing the product. So sum is your middle. So I'm just going to say the sum is going to be B. It's your middle number. And then your product, you're having to multiply the A and the C. So AC is going to be your product. So you have to multiply the A, which is the coefficient of your x squared, and then your C, which is your constant. Okay, so also notice that if there's an x to the fourth, it's very similar to your x to the x squared. So part 3, we're going to factor each expression. First thing I have to do is check for a greatest common factor. Notice there is no GCF. You're always checking for that first. So now what I want to do on these trinomials, there's three terms. I want to do sum and product. Sum is the middle number, -7. And product is your number that you get when you multiply these last numbers together. 2 times a -4. I'll go ahead and just write the step, which equals -8. So we're looking for two numbers that add to -7 and multiply to -8. So I like to start with my multiples of -8. So I'll start with my first one, -1 times 8. That will give me -8 when I multiply. But when I add them, it gives me +7. We want it to be -7. So what I could do here is just rearrange it to +1 times -8. That still multiplies to -8, and it adds to -7. Okay, so anytime I'm using sum and product, I'm going to set up two binomials. I have my variable y, because that's what this problem is calling for, and I'm going to use these two numbers that I find. So I'm going to add a 1 and subtract a 8. It does not matter which one. Now, remember when you factor, you're wanting it to equal each other. This does not equal my original. Anytime I have a coefficient in front of y squared, I need to divide it. So I need to divide both of those by 2. Okay, so after I divide it, then I have to reduce it. Okay, so if it can't be reduced, it's called the swing method. We're going to swing the denominator in front of that variable for that particular binomial. So that'll be a 2y plus 1. And then notice I can reduce this one. It'll stay as y. 8 divided by 2 is 4. So I should have a y minus 4. So you always want to divide it, but if it can't be divided, you have to swing the denominator and make it a coefficient in front of your variable. So remember, these should be equal. It should equal that. So if you wanted, you could check it by using FOIL. So this is the correct answer. When you use FOIL, combine your like terms, it does equal 2y squared minus 7y minus 4. Okay, so always check for a greatest common factor first. If they don't have anything, then you're checking to see how many terms you have. 2 terms. Today we were checking for difference of squares. 3 terms, we're always using sum and product. Okay, so part B. Notice there's a 4, but we said it's the same as your trinomial with an x squared. Okay, so I'm still going to use sum and product. So sum, so notice, first off, notice there's no GCF. My sum is always the middle coefficient, so negative 7. My product is multiplying the outside, so that's negative 8. So notice that that is very similar, okay? We just had that. We found the 2 numbers, so I'm going to have, it's B this time. B, we said one of them was a positive 1, the other number was a negative 8, okay? Now, we don't want it to just be a B, we want it to be a B squared since it has a B to the 4th, so make sure you're including that, okay? And then remember that number in front of the first variable, we're dividing by 2. So whatever that number is, we divide it by that number. We reduce. If not, we swing it in front. So if it can't be reduced, we're swinging it in front. So that's a b squared minus 4. Okay, so we used sum and product because it was a trinomial, and then we factored it. So now you're always checking at the end. So anytime I have an x to the 4th or a b to the 4th or whatever the variable is to the 4th, I always want to check and see if I can continue on because I'm still going to have a quadratic, which is a squared. Okay, so notice on squares, remember we can only factor difference of squares. So I won't be able to factor the first one. I'm just going to rewrite it. If you look at the second one, that is difference of squares. I can take the square root of both. So set up a binomial and a binomial. Square root of b squared is b. b times b is b squared. Square root of 4 is 2. One's a plus, one's a minus. So that way the middle terms cancel when I use FOIL, and I'm left with that b squared minus 4. So anytime I'm factoring, I want to factor completely. So I want to keep going until I can't factor anymore. All right, let's look at example 4. Remember, the first thing that you always check for is a greatest common factor, and notice they do have something in common. The first term is negative, so I know I'm factoring a negative out. Also notice the greatest number that will go into all 3 is a 4. Notice that all 3 of them don't have a variable in common, so this is my GCF. So I'm starting out with putting my GCF in front, and I'm dividing it to reduce it. So that's going to be an x to the 4th. That's going to be a minus 4x squared. And then that will give me a positive 3. So remember, to get that, we're dividing it by that GCF in front. Okay, so after I take out my greatest common factor, I need to look to see if I can continue on. So I took out a -4. Now I'm only paying attention to this inside piece. It is a trinomial, so I have to use sum and product. So the sum is -4, the middle number. Remember, your product is what you get when you multiply. Now notice here that this is a 1 in front times 3, which is just 3. So I want to find two numbers that add to give me -4, multiply to give me +3. Anytime I have a product that's positive but a sum is negative, that means they both have to be negative. So -1 times -3 will multiply to +3 and add to -4. So I'm setting that up. Bring down your GCF because we want it to be equal at the end. Notice I have an x to the 4th, so I should start out with the x squared on both of them because when I multiply them, I want x to the 4th. And then I have a -1 and a -3. Okay, so once I have factored, I want to look and see if I can keep going because remember, x to the 4th is tricky because sometimes you can keep going. So when we go to an x squared, we want to see if we have difference of squares. So notice we're both subtracting here, but 3 we cannot take the square root of. We can take the square root of 1, so I can only go another step with this piece here. So that would be x plus 1, x minus 1, and then I'm bringing down this one. Now, the reason I can't rewrite that one is because nothing multiplied together of the same term would give me a 3, okay, not a whole number. So that wasn't difference of squares because 3 was not a perfect square. So that would be my final answer, and it doesn't really matter what order you write it in. Okay, so let's look at the last one. So first thing I check for is the greatest common factor. I'm trying to figure out if there's anything that will go into all three of them. Notice they don't have a variable in common, and nothing will go into 3, 20, and 12. So there's no GCF. So since this is a trinomial, I needed to use sum and product. Sum is the middle number, and product is what I get when I multiply those together. So 12 times 3 is 36. Okay, so I just went over this. If your product's positive, sum's negative, both of them have to be negative. So I'll just start with the first one if you can't do it in your head. That way you don't skip it. That multiplies to give me positive 36, but doesn't add to negative 20. So keep going. -2, -18. Notice that does add to negative 20. So I should have two binomials. And notice it's a t to the 4th, so I should have a t squared and a t squared. I'm going to have a -2 and a -18. It doesn't matter which one you put where, but the signs do matter. All right, so after I do that, remember t squared times t squared does not give me the very first term, which is 3t squared. Whatever that leading coefficient is, I have to divide it. It's called the swing method. If I cannot reduce it, I swing the denominator in front. That becomes 3t squared minus 2. So that numerator stays there. The only thing that carries over is the denominator. I can reduce the next one. That would give me 6. So remember the t to the 4th, x to the 4th, whatever the variable may be, you always check to see if you can continue on. So t squared, x squared, whatever it is, look at it. It's difference. Both of them are difference. But 3 is not a perfect square, 2 is not a perfect square, and neither is 6. So if it's squares and it's two terms, but it's not the difference of two perfect squares, you're not going to be able to factor it. So that's as far as we can go. So sometimes you can continue on, sometimes you can't. You have to recognize perfect squares. Okay? So these are a few of the polynomials that we're going to be factoring here. So make sure if you have any questions over factoring that you let me know. Remember, the first step is always checking for that greatest common factor.